Good afternoon, everybody. We're going to go ahead and get started with our last formal lab of the semester. We will meet the Tuesday after Thanksgiving, and we'll have an activity designed to help you get working on your final project, during that time. But for today, we're going to go over and learn about the implementation of our final data structure for the semester, the hash table. The context for this project is we're going to implement a hash table that'll be part of a simple machine learning algorithm that will enable the computer to learn to play tic-tac-toe effectively. Now, what does this have to do with hash tables? Simply this. Tic-tac-toe is not that complicated a game. Anybody know how many possible positions there are in tic-tac-toe? Well, there's a lot more than 9 distinct positions, right? Because there are lots of combinations of markings of pieces. So how would we think about calculating the total number of positions? Here it goes. For each square, there are 3 possibilities, right? What are the possibilities? XO or empty. Good. So if you've got 3 possibilities in one square, then the next square has the same 3 possibilities. All possible combinations are there for those 2 squares, and so how many combinations would that be? You got 3 possibilities in one square, 3 in a second square. How many total are we looking at? 9. Yeah, 3 times 3, right? We've got XO blank for one, XO blank for the other. There are 9 possible pairings. So if we take 3 to the 9th power, that gives us the total number of tic-tac-toe boards. And so what we're going to do in this lab actually is store as many of those positions as are encountered in a hash table. Accompanying them, there'll be a value in the hash table, and that value is going to be how often that position led to a win, and how often it led to a loss, and how often it led to a... What this lets us do then is have our AI consult every time it encounters a specific board position in tic-tac-toe. It can imagine, if you will, every possible legal move it could make. And for each of those moves, it can ask the hash table, what's the win-loss ratio for this position? It'll then pick the move, the outcome most likely to lead to a win. This is, again, very straightforward to implement with a hash table. And so that's what we're going to be doing. So here is what the user interface will look like once everything works. If you try to run it now, it's just going to crash. But it colors the different squares depending on the probability of that square leading to a win. So it automatically will pick a shade of green if it's better than even chances for a win. And the better the chances are, the darker the green will be. Similarly, the better the chances are of a loss. So let's look at this example position to get a feel for what this involves. This position down here is colored dark red. Why do you all think that might be the case? Because it's O's move. Because if O goes there, X goes here, and the game's over. So looking it over, in fact, it turns out O's best possibility for a win is to block X over here. And this strategy as such simply emerges naturally from the computer playing large numbers of random games. It can also learn on the fly from playing with a human, but ultimately it has to do a certain amount of random self-play to really get the numbers up enough to make some good predictions. And so the user interface has a train button where you can tell it the number of games for it to play against itself randomly. And it'll use that information for its predictive model. So it's pretty fun. Once you get this working, I think you're going to find it pretty fun to play against and to see what it's capable of doing. So here are the pieces to put together for creating a hash table. We've got a little warning here. In your code below, follow good coding practices. For example, noticing when you are writing essentially the same code twice, and when you find yourself doing that, abstract it into a private method. In the last few labs, we've essentially been performing this for you. Like, for instance, think about the try. The find method was a way to factor out lots of common code and make everything go more easily. Part of what I want you working on this week is using your own insight to determine when a helper method needs to be created. And I'll give you a hint. At some point, you should realize this. So be looking for opportunities. So the first method you're going to create is an index method.
Where's this index? It's not on the main hash table.
Let's give it a look. It is right here, Morgan, on line 56 of hashtable.java.
Oh, thank you.
Yeah. So going back here, first method element is index. When you give it a key, it'll find a hash table index by calling the hash code method of the key, and it'll use modulo by the length of the array. Once you do that, you also need to take the absolute value because modulo can actually yield negative numbers in certain situations. So be careful about that. And then that one should be very straightforward. That should just be a couple minutes. The put method is the next thing to implement. You give it a key value pair. You first have to use index from step 1 to figure out where in the array it's going to go. And if you don't find an entry there, you'll create a new hash node to store that key and value. If there's already a hash node there, check to see if the keys match. If they do, you replace it. Otherwise, you walk down that linked list of hash nodes to figure out what you need to do. When the load factor of the hash table exceeds 0.75, put should double the size of the array and put everything back into the array. The get method finds the associated index using the index method from step 1, and then walk through your list of hash nodes to find your value if it's there. Successful solution for 2 and 3 will pass test put get, test capacity increase, test duplicate, and test very bad. Now, something you might consider doing is work on the basic case of put first without worrying about the resizing, and then get your get working. Then you can get test put get working. And once those work, you can go back and see about the resizing. That'll be handled with test capacity increase and so forth. All keys returns all of the keys in the hash table in some unordered fashion. So you're going to have to walk through your array and walk through each linked list in the array and put all of those keys into an array list that you're going to be returning. Once you've gotten test keys passed, you'll be ready to play tic-tac-toe. So when you're ready to play tic-tac-toe, I want you to bring up the user interface and just do some experimentation to figure out how many training iterations do you need for the AI to never be defeated when you play against it? Talk through strategies you attempt to use to defeat it and characterize whatever strategy you see it as manifesting. Now, in step 6, we've observed that there are a lot of classes in place that are necessary to execute this lab. You're really only working on one of them, the hash table. There's quite a lot else there. This level of complexity is going to be the level of complexity that we'd like you to aim for in the final project you'll be doing for this course. To conceptualize these pieces, we want you to draw 2 diagrams. One captures the class hierarchy and the nesting of classes on what's called a component has a level. In other words, you draw a diagram saying this objects of this class are inside objects of this class and so forth. So you think about what are the classes of the instance variables in the various classes in the application. So to do this, you're going to have to read all the source code very carefully. And that's part of what we want you working on with this lab. The second diagram should talk about the flow of execution. So you should be reading through the GUI code, seeing what happens with a button press and so forth. You can either use paper to do this or a tool like draw.io. And then you can hand it in either, ideally what I'd like you to do is scan it and then upload it into Moodle once you're done with it.
What about Draw.io?
Or use Draw.io, which is a lot prettier.
And just toss that link to that into the,
Yeah, that'll be fine as long as we can find it.
okay.
Yep. So that's the lab. Any questions? All right, happy tic-tac-toeing.